Good morning, everyone. Back at you here with some Trig Identities second video. Starting you off with the CoFunction Identities, okay? Just a little idea over here. I've put in a little right triangle, ABC, with side lengths X, Y, and R. And I wanted to take a sec and do a little kind of explanation about what these cofunctions are going to show us. All right, so let's, in respect to angle A, if I ask you for the sine of A, cosine of A, and the tangent of A, I'm pretty sure you all could tell me what those ratios are by your friend SOHCAHTOA. So like if you did angle A up here, sine would be Y over R, cosine X over R, and tangent would be Y over X. Okay, and again, we've been talking about those, so no surprises here. All right, then if I flip to angle B, all right, and we did the same kind of thing. This time, sine of, let's do green here, sine of B, cosine of B, tangent of B. All right, so we're looking over here, angle B. So this time, we're going to have X over R, Y over R, and X over Y. Okay, so what's happening in here, because A and B are complementary angles, okay, that's where our in the cofunction is going to come from. Complementary angles. Okay, all right, so let's take a look, see exactly what these cofunction angles are. And again, if you have your trig sheet that I provide for you on your packet, we're going on the far right side and going to go down through these and see what we have here. All right, so let's begin with the sine. Okay, so sine pi over 2 minus theta. Okay, well, that's just going to be the same as cosine theta. Okay, well, if that's the case, then cosine pi over 2 minus theta, well, guess what? That works out to be the sine of theta. Okay, so cool. All right, so let's see about tangent. Tan of pi over 2 minus theta is cotan. And then the cotangent of pi over 2 minus theta comes out to be the tangent. Okay, so they're cofunctions. All right, last up, secant. Pi over 2 minus theta. I bet you're gonna guess this one. Or are you? All right, cosecant. Then if we do the cosecant, pi over 2 minus theta comes out to be the secant function. All right, so cofunctions, we're just flipping around with the idea of complementary on those. All right, so again, those are featured on your trig sheet, and if you don't have that, you can certainly add the cofunctions to that list. All right, next up, odd and even identities. Okay, we haven't talked about odds and evens for a while, but it was the idea, if we were to substitute in the opposite of x, what would we get? Well, the sine function itself happens to be odd, so we get the opposite, or the negative of sine x. Okay, also in that situation is cosecant of negative x comes out to be negative cosecant of x. All right, because these are odd functions. Okay, even functions happen to be your friend the cosine. So cosine of negative x is just cosine x, no sign change. Okay, so that if that's true for cosine, it also works for secant. Again, even functions come out to be the same as the original function. All right, and it works out that odd function for tan is odd. So if we put tan of negative x, you get negative tan x. It's a negative sign there. So cotan is also an odd function, so we get negative cotan x. Okay, and again, these live on your trig sheet. If you don't have one, add them to a new one. Okay, All right, so what are we going to do with something like this? Okay, let's do a couple examples here. All right, so let's say if the cosine of theta is equal to 0.34, and I say find the sine of theta minus pi over 2. Okay, so your first thought is, oh, all right, cool. This one, it's got the pi over 2 in it. It's got the theta in it. We just talked about it. Well, not quite. Okay, reversed. Okay, we have it in there reversed. Okay, so instead of doing sine, let me write this down, sine of theta minus pi over 2, we need it to be pi over 2 minus theta. Okay, so that's actually put a negative of sine pi over 2 minus theta. Okay, so then we're in business. Okay, well, so what does that mean? Well, if you look back up here, sine pi over 2 minus theta happens to be cosine, right? So this is just negative cosine theta. All right, well, cosine was given to be 0.34, so we get negative 0.34, and that would be your answer. All done. All right, so what else can we use these identities for? All right, a couple more examples here. Let's say I ask you to simplify sine cubed x plus sine x times cosine squared x. Okay, and I want you to simplify that out as best you can. All right, well, first thing I notice, maybe you notice it as well, we have some signs in here. Okay, well, let's factor one of those out. Let's say we factor out the sine of x. Okay, so I would be left with sine squared x plus cosine squared x. Okay, all right, and now, whoopsie, now happy face, because in the back of your mind you say, oh, I remember in the other video and on my trig sheet, sine squared x plus cosine squared x. Huh, what's that? Well, if you look, okay, you see why I said you're smiling, because it's sine x times just 1. Okay, so your simplified answer, just sine x, and you're all done. All right, fantastic. Fantastic. And about now you're like, oh, what was that? All right, let's hit you again. Let's try this again. All right, let's try simplify cosine cubed x plus cosine x sine squared x. Okay, all right, so you're thinking, look at that, I got cosine, I got cosine. Okay, let me get back here, cosine, cosine. All right, let's see if we can factor that out. Okay, so pull them out, cosine x. All right, what's left? Well, cosine squared x plus sine squared x. Oh, I'm getting really excited now, because guess what? There it is again. Okay, cosine squared plus sine squared. Okay, oh yeah, that is just 1. So your simplified answer is just cosine x. Awesome. Okay, we're 2 for 2. Let's see what else I've got cooking over here. All right, let's try this one. Okay, and again, just to have a few examples so you kind of see where we're headed with all this stuff. And it's going to say simplify. Simplify by expanding. Okay, all right, so here's what we're going to start with. We're going to have secant x plus 1 times secant x minus 1. And we're going to put that all over sine squared x. Well, isn't that special? Okay, well, if we're going to expand, that means we have to do FOIL up top. okay? So if you over to the side do some FOIL over here, you're going to end up with secant squared x minus 1, and we're still all over sine squared x, okay? And I could do that FOIL for you over here to the side. Secant squared x minus secant x plus secant x minus 1. So you see those secants cross out in the middle. Okay, that's what I did. All right, so now looking at your trig sheet, okay, do you have a Pythagorean identity that involves the secant squared? Okay, somewhere there should be something about the secant squared. In fact, on my trig sheet I have laying here, I see 1 plus tan squared theta equals secant squared theta. Okay, so 1 plus tan squared theta equals secant squared theta. Okay, well, that's sort of what I have. Okay, oh, what's that you're suggesting? Oh, good idea. Subtract 1. So secant squared theta minus 1 is tan squared. Okay, cool. Let's substitute that in there and see what that does for us. So let's say tan squared theta over sine squared. Oh, I switched to theta. My bad. We have x, don't we? Sorry about that. Don't want to mess you up here, okay? So tan squared over sine squared. Well, let's break that down. Well, what is the tangent squared? Well, if we break it into sines and cosines, that would be sine squared x over cosine squared x. Okay, so that's just your tangent. Okay. And that's all over sine squared x. All right, so if we bring that up and treat it like this is over 1, so sine squared x over cosine squared x times 1 over sine squared x. So we're going to bring it up, multiply by the reciprocal, okay? So then your sine squareds can cancel. So we're 1 over cosine squared x. What's 1 over cosine squared x? Somewhere on your sheet you should have a secret that will let us say that is just the secant squared of x. And that's your final answer. Okay? So it's sort of like you're working a puzzle. You have to go through each of these problems and you're looking for things to substitute. You try to break things down into sines and cosines when you can, because most times that's kind of where you want to end up anyway. Okay? All right, now up to you, but I'm going to show another example here, maybe even 2 on the video. If you need to pause and work on something or go get a drink, go for it, and then come back and join in. Okay? All right, next one. This is going to be simplify by combining fractions. Combining fractions. That sounds interesting. All right, so here's what I have for us. Cosine x over 1 minus sine x minus sine x over cosine x. And it says to simplify. Okay? All right, so for this one, the excitement is going to be we need a common denominator. Okay, back to your fraction adding days. Okay, so that denominator is going to be the whole denominators that we see here, the 1 minus sine x and the cosine x. All right, so 1 minus sine x, cosine x. 1 minus sine x, cosine x. I don't know why I put an extra parenthesis on there, I just did. Okay, so on the first one, on the top, we have cosine x. Okay, so what are we going to have to multiply that by? well, the existing denominator, I don't want green, is 1 minus sine x. Okay, I've got that. So I need to multiply by cosine. So on the top, it's going to be cosine x times cosine x. Okay, on the second one, the second fraction, I have cosine. So I'm going to have to multiply by 1 minus sine x. 1 minus sine x. So on this top here, I have sine x times 1 minus sine of x. Okay, I'm going to scroll up here a little bit. All right, so what do we have now? Well, cosine times cosine is cosine squared x, and it's all over this denominator. Okay, minus. On the right, I'm going to go ahead and distribute. So I'm going to have sine x minus sine squared x all over the same denominator. The only thing I can say about this, sometimes I feel like you get writer's cramp. Okay, all right, now let's combine the fraction. So on the bottom, we're going to keep 1 minus sine x times the cosine x. Okay, on the top, cosine squared x. Now be careful with that minus sign right here. Okay, make sure it goes to both your terms. So we'll have a minus sine x and then a plus sine squared x. Okay, so cool thing about this, all right, so I see this right away, but I've done 10,000 of these in my life. I happen to see cosine squared plus sine squared. Cosine squared plus sine squared is just 1. And then it leaves a minus sine x behind. All over 1 minus sine x times the cosine x on the bottom. Okay? Oh, but then look, how sweet is this? Now we match 1 minus sine x, 1 minus sine x. So we can cancel. Leaves a 1 on top, cosine x on the bottom. But 1 over cosine is, you're right, secant. And that's your final reduced answer. Okay? Those may be just a little tougher because, again, at the beginning, we have to get a common denominator. Okay? So you just got to be real careful with those and do them a little at a time. Okay? All right. So, again, if you need to take a break, hit pause and come back and join me for one last example. I think I'll give you one. Maybe we'll do 2 more. Well, let's see here. So let's see here. We have solving by Trig. All right, this sounds intriguing. Okay, so find all values in x that solve. Okay, so we want to solve cosine cubed x over sine x equals the cotan of x. Okay, and we're going to use, when we solve, we want to be on the interval from 0 to 2 pi. Okay, so that would be 1 trip around the unit circle. Okay, all right, so first thing I'm going to do is I'm going to take that cotan and change it into sines and cosines after I make you dizzy by moving my screen. All right, so cosine cubed x over sine x is going to equal cosine x over sine x. So again, I'm just replacing cotan with sine and cosine. Okay? All right, so then why don't we clear that? If we multiply both sides, okay, note to the side here, we're going to multiply by sine x, just to clear out that denominator, okay? So we're going to say here times sine x, and over here times sine x. All right, so what happens? Well, The signs cancel. Hallelujah. All right, now what? Cosine cubed x equals cosine x. Okay, so we're all in cosine. All right, so if you're doing like a normal little algebra problem, at this point to solve, you want to get this equation set equal to 0. So let's subtract cosine x on both sides. So cosine cubed x minus cosine x is going to equal 0. Okay, well, if we're solving, keep going. If you factor out a cosine now, you get cosine x, and then cosine squared x minus 1 equals 0. Okay, well, that's good. So what does that mean? Well, I'm going to go over here to the side again and have a thinking party, okay? We know cosine squared x plus sine squared x equals 1. Okay, so that should mean, if I reorganize my identity, that cosine squared x minus 1 equals negative sine squared x. Whoops, sorry about that. X. Okay, so in other words, if I subtract 1 and subtract sine squared x, we can reorganize that identity. Okay, so knowing that, we can now say this is cosine x times negative sine squared x. Okay, so I'm doing a substitution right here from what we figured out on the right side there. All right, okay, so now what? Well, cosine x equals 0, or negative sine squared x equals 0. Okay, so now you got to think on your unit circle, where is the cosine x equal to 0? So in other words, where is x equal to 0? Well, that should be at pi over 2 or 3 pi over 2. All right, now what about negative sine squared x? Well, if you divide both sides by negative 1, we'll have sine squared x equals 0, which means that the sine of x equals 0. Well, is that even possible? Well, you're thinking, what do you mean, is that even possible? Sure it is. That's on the unit circle. Well, here's what I mean. Sine x happens to be on this denominator, okay, in that original equation. So that can't happen, so we don't have a solution for there. So in the end, final answer, x is going to be pi over 2 or 3 pi over 2. Okay, that was awesome. Oh boy, you're saying that was really awesome. All right, take a look at this one, and it's going to be same direction, solve. 2 sine squared x equals 1. 2 sine squared x equals 1, and it says solve. All right, so we will divide both sides by 2. So sine squared x equals 1/2. Okay, you're right. Take the square root both sides. Don't forget, when you do that, you get plus minus. Okay, so we get sine x equals plus minus square root of 1/2. Okay, well, that feels awkward. So what is that if you simplify? Well, it's the square root of 1 over the square root of 2, or 1 over the square root of 2, which you know to rationalize. Square root of 2 over 2. Oh, yeah, that looks like something I have on my unit circle. All right, kiddos, so where are we going to find the sine of x equal plus minus square root of 2 over 2? Well, you know, on that lovely circle, on the 45s, right? At pi over 4, sine is going to be positive square root of 2 over 2. Okay, on around 3 pi over 4, on around 5 pi over 4, and then in the fourth quadrant, 7 pi over 4. That's where you're finding the plus minus radical 2 for y, because remember, y is the sine. Okay, so at the end of the day, Solving for x in this equation, it's just those 4 radian values. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Awesome, awesome, awesome. Okay, I think things are going pretty well here. I could throw one more solve in here. This one's going to be a solve by factoring. Okay, and again, if you're getting tired, take a break for a few minutes, go walk around the house and come back and see me. Just hit pause, that's all you got to do. Okay, all right, last example. This one is solve by factoring. Alrighty, solve by factoring. All right, so here's what we have. 2 sine squared x plus sine x equals 1. Okay, so we need to go through here and see what we can come up with. Okay, well, when you solve any other kind of degree 2 equation, we need to set it equal to 0. All right, so we will do that same thing here. Sine x minus 1 equals 0. Okay, and then you want to go through and try and factor that. Okay, some people tell you, well, you could do this. You could say that y equals the sine of x, and you could write it out to the side like 2y squared plus y minus 1 equals 0. Okay, so in your mind, that's what you're factoring. So if you want to do your usual slide divide bottoms up, we've got sine squared x plus sine x minus 2 equals 0. Okay, so I'm doing my multiply here. Then I want to factor that. So it looks to me to be sine x plus 2 sine x minus 1. Okay, and then remember to do your divide in the next step. So we have to divide by 2. Okay, reduce if you can. So sine x plus 1, bottoms up, 2 sine x minus 1. Okay, so we're trying to find where, if we solve here, sine x equals negative 1, 2 sine x minus 1, if I'm working this out so you see where this comes from. Sine x equals 1. So then this one is sine x equals 1/2. All right, so we got to think about where is the sine negative 1. And again, your friend, the unit circle. So down here, 0, negative 1, there's where the sine is negative 1. So where am I? I'm hearing you, I think. 3 pi over 2, you're right. So here, x is 3 pi over 2. All right, then we've got to think about where is sine 1/2. Where is the sine 1/2? Okay, so here at pi over 6, we should be square root of 3 over 2, 1/2, there he is. And then over here in the second quadrant, if we come around the circle, we're at 5 pi over 6. Aren't we here at negative square root of 3 over 2, 1/2? Yes, indeed. So this x here, pi over 6, 5 pi over 6. And you thought I was kidding when I said that unit circle was so important. Well, there it is. All right, fantastic, everyone. I know that video was kind of long, but I hope that helped. At least you have some examples to go by with your book assignments and some work you have on some handouts in your packet. Okay, and again, make sure you're using that Trig identity sheet because I think it's worth its weight in gold. I wish you the best. Take care, everyone.